Okay, so this is our new topic in geometry, and it's what I call the inner and external angles. So here we're talking about inner and external angles on any polygon, a triangle, a square, an heptagon, octagon, etc. There are a couple of things that I would like you to remember. The very first one, let's talk about inner angles. And what is the sum of the inner angles? So let's start again with the basic one, the easiest one, that is a triangle. So we have mentioned before that if we have this, and this is x, and this guy is y, and this guy is z, so you know that the sum of the inner angles, which will be x plus y plus z, is equal to 180. But very few people know why. Like everybody remembers this from school, but there is a little theorem that is going to be very handy in the exams that help us to know what is the sum of the inner angles of any polygon, okay? In a triangle, we know that is 180. Try to think on what would be the sum of the inner angles of, I don't know, this figure. It could be a square, right? So what will be the sum of these four angles? And I will get that many of you will be able to say that the sum of the angles, right, is equal to 360. And that will be correct, okay? But why? What happens if I have this figure? Let's call this guy, I think that is going to be an hexagon, okay? So what happens if I need to know what is the sum of all these 6 angles, okay? What is the sum of these angles? So what I want you to remember is the following little formula. That is, and this is given for the sum of the inner angles, okay? The sum of inner angles right here is given by this formula. N minus 2 parentheses times 180, okay? Where N represents the number of sides in a triangle. Well, in a figure, sorry, not necessarily a triangle. I was thinking of giving the example of a triangle. N is the number of sides of the figure. So, for example, let's take this expression into the triangle. So, n minus 2, in this case, if we apply it, what will be the value of n? The number of sides. A triangle has 3 sides, so this will be 3 minus 2, everything multiplied by 180. 3 minus 2 is 1 times 180 is equal to 180, and that's why we know that the sum of the inner angles in a triangle equals to 180 degrees. What about well, not necessarily a square, a quadrilateral for that matter, okay? It is a quadrilateral, any figure with 4 sides. N minus 2, in this case, n is the number of sides, which will be 4 minus 2 times 180. So 4 minus 2 is 2 times 180. We get this thing to be equal to 360. So we know that the sum of the inner angles in a quadrilateral figure with 4 sides will be 360. Let's apply this concept into this figure that we didn't really know. So we apply n minus 2. Now, what is the value of n here? The number of sides. We have 1, right? 2, 3, 4, 5, 6. This is an hexagon. So we have 6 sides. So it will be 6, the number of sides, minus 2 times 180. 6 minus 2 is 4 times 180. This thing is normally 720. Will be the sum of the inner angles of a polygon or a figure, okay? In this case, specifically, 720 if the figure that we're talking about is an hexagon. So always. This is the formula that I need to remember. X minus n minus 2 times 180, where n represents the number of sides, okay? Now, as we have internal or inner angles, we have something that is called external angles. So first, let's guarantee what is the meaning of external angles. So external angles, let's write it down right here. External angles are the supplementary angles, to, with respect to the inner angles. A little review here. If you don't remember what is the meaning of supplementary angles are, the ones that take the inner, in this case, like take the inner to 180 degrees, okay? We'll do the examples for you to be super clear here. So let's start again with the triangle. So in a triangle, this that I'm drawing in yellow are going to be the inner angles. So let's see, this one's in red will be the external angle. So if this angle is internal, so if I make the projection, let's say that I continue or prolong the side, this guy here that I'm drawing in red, this will be the external angle. So the external angle will be the supplementary of the yellow one, or vice versa, because it takes me to 180. And we do the same. If I take this side and I prolong it, so this will be a complementary angle. If I take this side and I prolong it, this guy will be the complementary angle, the supplementary angle. So here, the angles in red, this is what we call external angles, okay? So this is an external angle, this guy is an external angle, etc. I hope that is clear. Let's do it with another figure. Again, it might be a quadrilateral, right? Now the quadrilateral is just 4 sides, so let's not draw a square or a rectangle just for you to think different. So maybe here I have one side, this is 2, this is 3, and this will be 4, okay? So again, in yellow, I'm gonna draw the inner angles, and if these are the inner angles, let's see which are the external angles. Again, I take this side, I cannot prolong it, so this will be external. Take this side and I prolong this side, this will be external. I take this side, prolong it, this guy will be external. I take this side and I cannot prolong it, this guy here will be external. Okay, those will be the external angles. And now, what is the nice, interesting part? The sum of the external angles, okay? Whatever happens, it doesn't matter which figure do you have, it does not depend on the number of sides of the polygon. The sum of the external angles is always equal to 360 degrees. Always. It doesn't matter which figure do you have, okay? So here what we're saying is that the sum of these 3 external angles in the triangle is equal to 360. The sum of these 4 external angles in this quadrilateral equals 360. If we have, again, let's say, the figure that we were working with before was kind of an hexagon. Again, we know which are the internal angles, so we just reduce the external one. So if I take this angle, okay, so the sum of this guy that is external, this guy will be external, this guy will be external, right? This will be external, this side will be external, and this angle will be external. So the sum of these 6 external angles, again, will be equal to 360. Always, does not depend on the number of sides. Just be clear which are the external angles. Remember, are the supplementary angles, and that means the external angle is that one that the inner one is missing to go all the way to 180 degrees. And the sum of those external angles are always going to be equal to 360 degrees. Okay, this is going to be very useful, and the way I have seen it in exercises in these exams, it'll be a time saver, okay, because you don't have to do all the process to deduce it. It's something that I know that you will be able to deduce, but we already know it doesn't matter. Sum of external angles, 360 degrees.